Very good morning, dear friends. Myself, Dr. Vikrant Sudhakar Palekar. I am working as an assistant professor in Gokhale Education Society's Arts, Commerce and Science College, Jawahar, Palghar. Welcome in the lecture series on the topic Bonding and Structure of Organic Compounds. This is the second session we are doing on this particular topic. So, till now in this particular topic, we have understood what is been by basically the term hybridization. So, basically, hybridization is nothing but mixing of atomic orbitals to form a new hybrid orbitals which is having equivalent energy as compared to the original orbitals and in which they are oriented in the space. So hybridization is very important phenomena in the formation of molecule. So this particular hybridization concept is help to describe us the structure and what are the bonding involved in that particular molecule. With the help of that, we can able to explain the geometry and bond angle in between the molecule and what is basically the hybridization of that particular molecule. So till now we have covered the SP3 SP2 hybridization of carbon as we nothing but SP3 hybridization is nothing but mixing of 1s and 3p orbitals to form new orbitals. So these equivalent orbitals are oriented at the tetrahedron of regular tetrahedron. So it is having bond angle 109 degrees. And in case of the sp2 hybridization, it is nothing but the mixing of 1s and 2p orbitals to form the new orbitals which is having equivalent energy and which are oriented at the trigonal arrangement, and it is having bond angle around 120 degree. So in this particular session we are now going to see the sp hybridization of that carbon. So basically sp hybridization nothing but the mixing of one of the 2s orbital and one 2p orbital to form two new sp hybrid orbitals which are having similar characteristics, and this particular hybridization is called as sp hybridization. As we know that carbon can exist in sp3 sp2 and sp hybridization. So basically as we know that carbon is having atomic number 6. So whatever the mixing takes place in which basically the phenomena takes place in the first step is in the hybridization is the excitation of electron. So due to the excitation there is a unpaired electrons are observed and which is equal to the valency of that particular atom. And in case of the carbon we have seen that the carbon is having atomic number 6. So these electrons are distributed as 1s2, 2s2 and 2p2. So this is a ground state electronic configuration. So in the excited state what happens, one of the 2s electron is promoted from lower energy level to higher energy level. So it is promoted from 2s to 2p orbitals. And in case of the sp hybridization, there occurs mixing of one of the 2s and one of the 2p orbital to form two new sp hybrid orbitals which are having equivalent energy. So these are the two hybridized orbitals, correct here, hybridized sp. So these are the two new hybrid orbitals which are formed, which are called as sp hybrid orbitals. While we can see that the py and pz orbitals remain as it is not take part in the process of bonding and hybridization. So they remain as it is perpendicular to the plane. So they will not take part in the bonding process. So these are the two new orbitals which are being formed. And basically we know that sp hybridization, it has a linear arrangement. Linear means straight. So it is having bond angle around 180 degree. So it is just like a finger. So it is having bond angle 180 degree. So remember this is a sp hybrid orbital. We will see how what is the geometry of that. So basically sp, one of the s means we know that spherical. So s orbital and p orbital, as it is a px orbital, so it is oriented at x direction. So these s and p hybrid orbitals in the second shell get mixed to form new hybridized orbital, which you can see the shape is just like a linear. So there are only two lobes. which are observed coaxially, while py and pz orbitals will remain as it is. You can see the py and pz orbitals remain as it is perpendicular to. So this is the shape of that yellow line. Yellow lobes are the sp hybridized orbitals, and here is the central carbon atom. So you can see the two lobes which are oriented around the x-axis, while py and pz orbitals remain as it is. So if we see three-dimensional arrangement, you can see these orbitals py and pz orbitals are perpendicular to sp hybridized orbital. So this is also diagram. So what happens when two sp hybridized orbitals they approach each other? So these are the two sp hybridized orbitals of two different carbon. So what will happen when they approach each other? What happens? These sp hybridized orbitals overlap with another, okay, axially. So what happens? These two overlap with one another and they form the sigma bond here, as in case of the acetylene we can see. And you can see the py and pz orbitals overlap to form the two new pi bonds, and as a result of that we can see this particular geometry in case of the acetylene molecule. In the next slide we can see. So remember always this sp hybridized orbital overlap and they form the sigma bond, while py and pz orbital they overlap laterally and they form the pi bond. So remember, in case of the sp hybridized orbital, it is having 50% s character and 50% p character. So it is equally distributed. As in case of the sp3 we have seen the s character is 25% and p character is 75%. In case of the sp2 it is 33% s character and 66% p character. So remember, for sp hybridization it is equally there. Now we are going to see the example of sp hybridization. As we know that triple bonded compounds are the example of triple bonded carbon compounds are the example of sp hybridization. So we will take the simple example of acetylene. So acetylene is having structure CH triple bond CH. So whatever the carbon covalent bond, it is formed by coaxial overlap of sp orbital of one of the carbon and sp orbital of another carbon. Already we have seen. And two pi orbitals are formed laterally by overlap of py and pz orbitals. Okay, and whatever the single bond which are present, they are formed by overlap of sp and s overlap of carbon and hydrogen. So you can see the bond angle is 180. Let us see what is the hybridization. So in case of the hybridized, carbon is having a central metal atom. It is having configuration 1s2, 2s2, 2p2. So it is 1s2, 2s2, 2p2. So this is these are the violet colors which are the basically mixed together to form the. So this electron is coming from the hydrogen. So two hydrogens, they will give, correct, here instead of 4 here must be 2. So two electrons which are mutually shared with the carbon, and here you can see this is a sp hybridized orbital, and py and pz remain unhybridized. So this is, here you can see in case of the acetylene. So this is a one carbon which is sp hybridized, and this is another carbon. So these are the sp hybridized orbitals, and here you can see the CH bond which is formed by the overlap of sp and s orbital of carbon and hydrogen. So they will overlap coaxially, and as a result they will form one sigma bond. So this is a sigma bond which is formed by coaxial overlap, while lateral overlap which results into the formation of one pi bond and one more pi bond. So there are two pi bonds that is formed. One is the overlap of py orbitals, and one is the overlap of pz orbitals. So this is a structure. Here you can see CH triple bond CH. So here you can see the bond angle is 180 degree. So it is a sigma bond in between the carbon and hydrogen, and sigma bond in between the carbon. While you can see these two pi bonds which are formed by the lateral overlap. So remember, acetylene is the example of sp hybridization for the carbon. So as we know that there is a triple bond, 1 2 and 3. So this, out of 3 bonds, 2 are pi bond and 1 is sigma bond. Remember always, 1 is sigma bond and there are 2 pi bonds. Each carbon has 2 unhybridized sp orbitals and they form the pi bond. So two unhybridized orbitals will form the pi bonds. Now we'll see the sp3 hybridization for the oxygen. As we have finished for sp3, sp2 and sp hybridization for the carbon. Now we will see for the oxygen. So for oxygen, we will see what is sp3 hybridization and what are the examples. So first we will define what is sp3 hybridization. As we know that sp3 hybridization is nothing but mixing of one of 2s orbital and 3 2p orbital to form 4 new sp hybrid orbital with similar characteristics. So what are the new orbitals which are formed, which are called as sp hybrid orbitals? So as we know that oxygen is central metal atom, it is having atomic number 8. So oxygen has 2 sp hybrid orbital containing 1 unpaired electron each, 2 sp hybrid orbital with lone pair of non-bonding electrons. So this particular thing I will explain you. So as we know that oxygen having atomic number, so how the electrons will be distributed? 1s2, 2s2, 2p4. So 4 plus 2 6 plus 8. So here you can see there are only 2 py and pz ऑर्बिटल रिमेन अनपेयर्ड. यहाँ पे 2 ही इलेक्ट्रॉन की ज़रूरत है. ओके, सो व्हाट हैपन इन केस ऑफ द sp3, 1s and 3p orbitals, they overlap. Okay, so in case of oxygen there is no excitation is observed. So what happens? There is no formation of electron also. So what happens? One of the s and one of 3p orbitals, they will combine and they will form the new sp hybridized orbital. Okay, so these particular orbitals are having tetrahedral shape and they are oriented at the corners of regular tetrahedron. So as we know that oxygen is divalent. So why valency of oxygen is 2? Here you can see, because there are only 2. So out of the 4, here you can see, out of the 4 there are 2 orbitals which are paired and 2 are unpaired. So when these orbitals are paired, that is called as a lone pair of electron or non-bonded electron, because they do not involve in the bonding process as such. So why oxygen is divalent? Why valency of oxygen is 2? Here you can see. So it is divalent with 2 lone pair of electrons. That's why always on the oxygen there are 4 electrons are shown. So there are 2 pairs dot dot on the oxygen is shown, because there occur the presence of lone pair of electrons on the oxygen. So here we can see the sp3 hybridized oxygen is bonded to 2 other atoms or groups. So remember always, oxygen has 2 friends. Oxygen can form bond with the 2 atoms or group. So remember, for oxygen with sp3 hybridization, it also have the regular tetrahedron, just like a sp3 hybridization in the carbon. Now we will see the shape. We will take the example. Now you should remember what are the example of sp3 hybridization for oxygen. So water molecule is very good example, H2O. So in case of the water, as we know that oxygen is a central metal atom, so it is having this particular configuration, 1s2, 2s2, 2p4. So these black colored electrons which are coming from the 2 hydrogens, correct? Here instead of 3 here must be 2. So what will happen? These 2 electrons are mutually shared with the oxygen and as a result of that you will find this 2s and 3 2p orbital mixed to form the 2 new sp3 hybridized orbital. Now here you can see, once the 2 electrons are mutually shared with the hydrogen, you can see the octet is complete. There is 8 electrons. So these are the 4 new sp hybridized orbitals are formed. So 3 2p and 1 2s orbital is which is formed, and is it having the shape just like a regular tetrahedron. So here you can see, so these two electrons, this pair is here, and this one of the pair will be here. So these two electrons here also you can see it is present, as it is unhybridized, or we can say lone pair of electrons. As we know that lone pair of electrons occupies maximum space, so maximum there is a electron density which is present on the two orbitals. So as a result of avoiding the electron repulsion, these orbitals will try to remain मैक्सिमम अवे फ्रॉम ईच अदर. वो जो दो ऑर्बिटल है वो रिपल्शन कम होना चाहिए, इसके लिए मैक्सिमम अवे रहते हैं एक दूसरे के. So that will have, when they stay maximum away from one another, in that case they will have the maximum stability and minimum repulsions. So remember, so here you can see here the oxygen HOH. So whenever we say the water molecule, the oxygen is central metal atom. So what is the bond angle? HOH, and this particular bond angle you can see it is around 10.5 degree. As we are saying that this is a tetrahedron, so what bond angle you must have? 109 degrees. So why it is less? Because there are presence of lone pair of electrons, while this particular case is not present in case of the methane. So there are two lone pair of electrons. So in order to avoid the repulsions, the bond angle get reduced. So we have to remember, for water molecule it is having a regular tetrahedral arrangement. Geometry you can say the angular, just like V, उल्टा V, यहाँ पे एक H है, यहाँ पे एक O है, यहाँ पे एक H है. So it is just like an inverted V shape, or we can say also bent shape also. The bond angle is 104 degree. So somebody asks you, or what is the reason for lesser bond angle in case of water as compared to the methane? So what is the reason? In order, if you see the water molecule, there are three kinds of repulsion is there, because there are how many types of electron? One is lone pair of electron, these two are the lone pair of electron, and these are the bond pair of electron. So there are three kinds of repulsions which are exist. So one of the repulsion is lone pair, in between the lone pair, then in between the lone pair bond pair, and in between bond pair. So this lone pair repulsion is higher than lone pair than bond pair. So in order to have the minimum repulsions, this particular bond angle get reduced, because this lone pair of electrons or that particular orbital is having maximum bulkiness in the atmosphere. So as a result of that, it push the bond pair towards itself, and as a result of that the bond angle get reduced. So this is the reason. Now we'll see the another example with oxygen having SP3 hybridization. What is the example? Alcohols. Alcohols are very good example. ROH, just like a water. Here we are replacing H by alkyl group, and as we know that alkyl group are generally bulkier than hydrogen, so the ROH bond angle in alcohol is generally large, that is 104.5 degrees than water. So this is a HOH bond angle is 104, but in case of the alcohols you can find it is 108.9. Why it is so? Because the presence of alkyl group CH3OH. In case of the methanol, you can see there is again tetrahedral arrangement with bond angle 104. So alcohol molecules also have two lone pair. So every oxygen molecule, let it be present in any hybridization, it will always have the lone pair of electrons, and this particular bond angle is around 108. In case of the water you will observe 1048, but in case of the alcohol you will observe 108. But in case of the ethers are also compound. What you observed the ethers, it is ROR. So both sides there is alkyl group. What is general formula for ether? ROR. So in case of the R, if you take the ethyl, CH3O CH3 or CH3O CH3. So same is the case you will observe the sp3 hybridization. This particular oxygen is having sp3 hybridization. This particular carbon is also having sp3 hybridization. दिस कार्बन इज ऑल्सो हैविंग sp3 हाइब्रिड. अगर कार्बन सिंगल बॉन्ड से अटैच है तो वहाँ पे कौन सा हाइब्रिडेशन होगा sp3. अगर वो डबल बॉन्ड से ज्वाइंट है तो वहाँ पे sp2 होगा. अगर वो ट्रिपल बॉन्ड से ज्वाइन है कहाँ पे भी एसिटिलिन हो या नाइट्राइल्स हो तो वहाँ पे sp हाइब्रिडेशन रहेगा. सो रिमेंबर दिस थिंग ऑलवेज. ओके. ऑक्सीजन सिंगल बॉन्ड से अटैच है तो वहाँ पे sp3. अगर डबल बॉन्ड से अटैच है तो वहाँ पे sp2 हो जाएगा. So this is a bond angle in case of the ether. Now we'll see the sp2 hybridization for oxygen. So again let us write the electronic distribution. 1s2, 2s2, 2p2. So in case of the sp2, what will happen? Only 1s and 2p orbitals will overlap and they will form the two new sp2 hybridized orbitals. So what happens? 2s and 2s orbital of oxygen is mixed with the 2p orbitals and they form the 3 sp2 orbitals. So 1 2 3, these are the 3 sp2 hybridized orbitals are formed and they will have electron pair. So they will have 2 electron pairs, these 2 electron pairs and 1. So one of the pz is remain unhybridized as it is. It will not involve in the process of bonding. So it will remain perpendicular to plane. So now we'll see the shape of the carbonyl group. As we know that what is a carbonyl group is having this is a structure, carbonyl group. These are the two, we can say, lone pair of electron. So there is a carbon double bond oxygen. So it is also having sp2. It is also having sp2 hybridization. Both carbon and oxygen will have sp2 hybridization. So what will happen? sp2 hybridization of carbon will overlap with the sp2 hybridization of carbon. As a result of that, so see, this is a carbon which is also having the sp2 hybridization. So it is having sp2 hybridization, this particular carbon, and this particular oxygen is also having sp2 hybridization. So they will overlap. So these sp2 orbitals will overlap and it will form biaxial overlap of sigma bond. So here you can see the sp2 hybridized orbital will overlap axially, while pz orbital, as we have seen in the last slide, the pz orbitals they overlap laterally and they will form the pi bond. So in between the डबल बॉन्ड जहाँ पे हमेशा रहता है वहाँ पे याद रखने का कि एक जो बॉन्ड है दैट विल फॉर्म बाय द सिग्मा बॉन्ड and another bond will be pi bond. Pi bond is formed by the lateral overlap. So in carbonyl group, both carbon and oxygen are sp2 hybridized. Carbon and oxygen both are sp2 hybridized. So one of the sp2 orbital of carbon and oxygen having unpaired electron. So here you can see it is having unpaired electron. So these two are the lone pair of electrons. Okay, for on oxygen, not on the carbon. Huh? It is only present on the. So this is the one unpaired electron for both carbon and oxygen. So they will overlap and they laterally they will form the pi bond. Axial overlap CO sigma bond and lateral overlap they will form the CO pi bond. In case of the aldehydes, as we know that carbonyl compound can be aldehyde, can be ketone, can be acid, can be ester also. So in case of the aldehyde also you can see R, C, H and double bond O. So on oxygen there will be the sp2 hybridized orbitals which are non-bonded or lone pair of electrons, and pi bond is formed by the lateral overlap of pz orbital of both carbon and oxygen. So same is the case of the ketone. In case of the ketone you will find RCR bond here. So same is the thing. Pi bond is formed by the lateral overlap. This is also sp2, this is also sp2 hybridized. बीच का जो बॉन्ड है that will be sigma and one bond is pi bond. So same is the case in the case of the carboxylic acid. O H O एसिड का स्ट्रक्चर कैसा है R C double bond O O H. Okay, so this is also sp2 hybridized. This is also this is sp3 hybridized, this is sp2 hybridized, this is sp3 hybridized. So lateral overlap, they will form the pi bond, and coaxial overlap of sp2 of carbon and sp2 of oxygen will form sigma bond. Same is the case with the esters also. So remember, carbonyl group is always a good example of sp2 hybridized carbon and oxygen. So go through this particular session uh, for sp2 hybridization of carbon and oxygen we have already finished. Only thing is that remain is the nitrogen. So nitrogen we will see in the next session with some examples. Thank you very much.